Okay, so we're going to go into Instantaneous. Rate of change. Okay, and for us, there's another way of saying slope at a point. So an instant rate of change for us is looking at, let me give you a dumb example of a line. Oops, I'm looking at these Zoom notifications. Okay, we're gonna go y is equal to 3x plus 2. Now that is a graph of a regular line. The regular graph of a line looks like up 2 and over rise, 1, 2, 3, over 2.
I think Gabe's in the waiting room.
Well, the thing is, I have no waiting room. I let a bunch of people in already, but I think Zoom is acting up also. Oh, Gabe's in now.
I'm in. Thank you.
Yeah, I didn't see anyone in the waiting room till like they just started populating right now. Okay, thank you though. So here is a line equation. Now let me ask you this question. Oh, I think what happens is Zoom is semi-creating new rooms at the same time. So you're seeing a bunch of notifications on top. Like those normally don't show up unless if the room isn't created yet. But the room's created, we're here. Hey Jess. Okay, so,
Hi.
oh, I should turn on my camera. Okay, let's spotlight me. Let's see. Okay, sorry about that. So, my question for you, at any point on this line, what is the slope? What is the change going on? I would liken this to almost like the stock market. If you ever see the stock market, hopefully you're not paying attention too much to it, but you see it go up and down, and now it's like down, right? So at every point throughout the day, you can tell yourself, am I making money or am I losing money? Is the slope positive where I'm going to gain value, or it's negative where I'm losing value? And as you can tell, at every point of this graph, it's actually always different. It's different at every moment. So this line here, is it different at every moment? It is actually a constant rate of change. So we demonstrated that you could find slope by taking the slope equation, m is equal to y2 minus y1 over x2 minus x1. And in this question, for instance, we can do 2 comma 5. I think that's what it was, 2, 5. Oh, no, it's, sorry, 1, 5, 1, 5. And this point here was 0 comma 3. And the way we did that, we just subtracted 5 minus 3 over 1 minus 0. And that came out to, whoop, this was a 2, I'm sorry. That's a 2. We end up with 3 over 1, which is our slope. And no matter which 2 points you pick, it's always going to be 3 because it's a straight line. So in our last class, we said, hey, what if we switch that to, instead of 2 exact points, we called it this instead, x comma f of x. This is your y value, right? And our new point would be x plus h with our new y value of x plus h, f of x plus h. Where instead of saying, hey, these are 2 separate points, we're going to define both points by an x, and the second point will be just shifted over, shifted by h units away. And that led us to a new type of slope equation where our slope was f of x minus, whoops, let's go the other way. Let's try the new version. F of x plus h minus f of x over new h minus old h. Okay, where this was in a sense y2, y1, x2, x1. It's pretty much the same equation as before, except I generalized it. And we could simplify this to be f of x plus h minus f of x over h. And the reason why it's h, because if you look at the x's on the denominator, x and negative x would always cancel out, leaving me just h. Now the crazy part is that this defines still rise over run, where f minus f is how far you changed in the y direction, and h is how much you shifted over in the x direction. And you guys worked on IXL about this. Now, for us to look at this as a picture, let's take a look. We graphed it out, let's say. And if I want to find the slope at, let's say, 1 here, we start off with talking about this as a secant line. What would the slope of 2 points be? And in order to find the slope of this 1 point, the instantaneous rate of change, we said the secant line would have to turn into the tangent line. That the 2 points would have to literally be sitting on top of each other so we could use that slope equation. So today what we're going to do is we're going to say, you know what, this h, these 2 points are not going to be very far from each other. They're going to be literally sitting on each other's laps. As h approaches 0, it is going to be the same point. So how far do you want those 2 points to find slope? I want them to be on top of each other. They're the same point. So today, we're going to work on this limit way of finding slope to find instantaneous rate of change. So let's look at our previous example. So what is the instantaneous rate of change? What is the slope? Y equals to 3x plus 2 at x equals to 1. Let's make this up. And we'll see if we're still going to get the answer 3 like we did before when we just plugged in 2 easy points. But since we generalized it, we're not going to plug in any points. We are going to plug in this f of x into this equation here. F of x into that equation, and our upgraded version into this equation. Okay, so the limit as h approaches 0, we copy that. Now, f of x plus h, please take a look. It's just x with the upgraded version. You have the new iOS on your phone? Just a new version. Everything else is exactly the same. Only that x number changes. So we're actually going to copy this in the front. So f of x plus h becomes 3 parentheses x plus h plus 2 minus the original f of x, which is 3x plus 2, all over h. I'm going to pause here just to make sure you guys are all on the same page. Now that we set this up, let's go ahead and simplify this. First thing is if I just plugged in 0 here, if I just plugged in 0, we'll see that x plus 0 is just x, 3x plus 2, minus 3x plus 2 over 0. Hey, isn't that just 0 over 0? Well, yeah. If I told you y2 minus y1 over x2 minus x1 were exactly the same x and y's, that still be 3, not 3. This point would have been 2 minus 2 over 0 minus 0. That would be 0 over 0. It's the same point. As h goes to 0, they should be the same point. And you end up with this undefined problem. And in this point, it's indeterminate, which is what we want. So here we go. Instead of plugging in, we're going to try another way. Let's go ahead and multiply it out. We have to write the limit because I didn't plug it in. I'm just simplifying. Now, the cool thing is that you will always find stuff to cancel out. 3x, 3x, 2, and 2. So we're left with the limit as h goes to 0 of 3h over h, which is perfect because Remember how we ended up with 0 over 0 over here? Remember how we ended up with 0, 0? That's our 0 over 0. We have found the spy. Anyone playing Among Us right now? Where you have to find the traitor?
Yes.
Among Us
Right?
is so fun.
Oh, yeah, I know. That's unfortunately. But see, we're looking for the bad guy, right?
Imposter.
The imposter. Thank you. We found the imposter. Bam. The limit as h goes to 0 of 3. You can't plug in 0, right? We're done. The limit of a constant is that constant. We found the imposter. See, when there's a 0, 0, you know there's an imposter in the group. Gotta find the imposter any way possible. Okay. All right. Among Us, the best way to lose friends. Okay. We'll do another type of this problem. So we're going to look at the different types and styles that we'll see our ability to use this slope equation, this instantaneous rate of change, to find. Okay. Okay. So we're going to try another problem. Let's use x squared plus 2. That's our f of x. And we're going to find the slope. Oops. To answer the question, what is slope at 1? The slope at 1 is 3 because there's no variable. It's always 3. Hey, the slope for our line up here is always 3. Remember, it's always, oh, come on. It was always 3, no matter where we're at. Now, we're going to change the problem to a parabola. Now, for sure, this is not a constant slope. That is not a constant slope. And it's going to change. You give me an x, I'll give you a new change. I'll give you a new slope. If I pick an x on the left side, look, that's a negative slope. If I pick on the right side, that's the positive slope. Now, how are we going to account for that? We can. So we say, so find the instant rate of change at x equals to 1. Now, if we tried to plug in 2 points, I pick 1 and another number, this slope does not reflect the slope of that point. So our goal is to get the 2 points so close together, still using that slope equation, that h is 0. How far are they apart away from each other? They're exactly the same. It's like when I tell people, yeah, I have a brother. Oh, how much older is he than you? Or how much younger than you? We were born on the same day. What do you mean you're born on the same day? We're twins. Oh, crap. Are you guys the same person? Actually, in fact, we are. Though twins are birthed at different times, remember, they're conceived in the same instant. They are the same person. And after they've been formed, that's when they split. So twins are actually not older or younger than each other. They're actually the same exact age. We just try to say that they're older because one has to be dominant. Me. So x plus h. Our x's are all now x plus h squared plus 2. Now, me writing it separately like this is helpful to some people because they can see the 2 different versions, the x plus h and the non-x plus h. So to write this, we're going to write the future minus the past, or we can say this the present, all over h. Just so you can see that, we're going to copy this now. This is just, remember, the slope equation in a fancy form. It's just mac and cheese, but with a little bit of bacon. X plus h squared plus 2 minus the original x squared plus 2 all over h. Now, you don't have to do this, but I'm going to do this just to show you guys to prove a point. If h was 0, that these 2 points were so close together that they're on top of each other, if I plugged in 0 here, we would end up with x squared plus 2 minus x squared plus 2 all over 0, right? If h was 0, plug it in, and we end up with 0 over 0. We got an imposter. Okay, so let's hunt him down. we know with 0 and 0, indeterminate means find another way. So our other way is multiplying it out. It's not the best way, but it's our only way. X squared plus 2xh plus h squared plus 2 minus x squared minus 2 over h. Now again, just to remind you, whenever you're squaring a binomial, okay, there's a trick. You square the front, you square the back, and you double the middle value, which would be 2xh. Always that same pattern. Square the front, square the back, double the middle. And the reason why, just as a reminder, is when you do multiply it out, look, don't you have x squared? Duh. Don't you have h squared? Duh. Remember you have the middle terms? And they're always going to be twins. xh, hx, you always end up with two of them. Okay, no matter what. Pass away. Now looking back here, we have some like terms. x squared, 2 and 2. And we have the limit as h approaches 0 of 2xh plus h squared all over h. And you can see if I plug in 0, I end up with 0 over 0. To make this a little prettier, limit as h goes to 0. I want to factor out the h to make that super obvious. That imposter is standing right in front of us now. And that's where our 0 over 0 was. Yep. That's our 0 over 0. We then divide it out, and we're left with the limit as h goes to 0 of 2x plus h. So we have super generalized this. Now, how far do we want these points apart from each other? We want them 0. So now we can plug in the 0. Our answer, final answer, is just 2x. Now, the cool thing about 2x, do we tell you how far the points were supposed to be each other? We're saying they're 0, right? And the point is that you just now have to tell me x, and I will tell you the slope. You tell me x, and I'll tell you the slope. And this works for the whole graph. Now let's see if this works. Let's go back and look at my example from before. So this was our basic idea of this graph. Now, I'm going to put up some points. If I said x is 1, like they asked me to, if x is 1, okay, the slope looks like it should be positive. And since our f prime, our derivative, our slope is 2x. If I plug in x, if x is 1, the slope is 2, a positive 2. Bam, that slope is a positive 2. That's how much it's increasing. What if I plug in 2? Does the slope look like it's more steep? Yeah. If I plug in 2, the slope is now 4, which is more steep. It's kind of doing what it's supposed to. Seems predictable. On the left side, if I plug in -1, -1, the slope looks negative to me. If I plug in -1 here, the slope is -2, just like the right side, because it should be balanced. If I plug in -2, the slope is -4. So it's balanced like the right side. It's totally predicting it. And the idea is that this slope equation, this instantaneous rate of change, is now super predictable. Okay, so we worked with x squared. If this was, just as a quick example, if this was x squared plus 2x plus 1, let's say this was your f of x, your f of x plus h would be x plus h squared plus, remember, every time you see an x, you swap it with our new version, plus 1. Okay, every time you see an x, you swap it with that new version. If this was f of x was x plus 2 over x squared minus 1, our f of x plus h would be x plus h plus 2 over x plus h squared minus 1. Every time you see x, we swap it. And then we do the simplifying afterwards, after you swap it. Okay, let's look at another example. So what happens if this looks like a fraction like we just showed? So let's use an easy example. F of x is equal to 1 over x plus 1. Let's do that. See what happens here. Okay, so my original f of x, we already wrote that. Our new version is 1 over x plus h plus 1, okay? That's my new version. See, I only changed the x and I made it the upgrade version. So for us to do this problem, we write the limit of as h approaches 0, and we're going to write our two versions there. 1 over x plus h plus 1 minus 1 over x plus 1 all over h. So the goal is to don't overthink it, just copy it. Now, do you guys remember how to solve this? How do we get rid of these fraction problems when it came to limits? Because if I go ahead and plug in 0 right now, we end up dividing by 0. So here's what we do. Let's go ahead and multiply by the common denominator. In this case, the common denominator would be x plus h plus 1 and x plus 1. And we do that to the top and bottom. Top and bottom. So it's ugly. That's what we do. So the limit as h goes to 0, the top, if I multiply to the front and the back, the fractions go away, and we're left with the top fraction of x plus 1 minus x plus h plus 1. No more fractions on top. H, and we're left with this bloody mess here. X plus h plus 1 and x plus 1. Do not distribute that denominator. I will save you time right now. Don't do it. On top, you see that if I rewrite this as a negative x, negative h, negative 1, do you see some terms that are going to cancel out here and subtract out? So I'm trying to save some time, not having to write out the whole thing. Let's write out the simplified version. The limit as h goes to 0 is going to be a negative h, which is all that's left over on top, and h on the bottom, and these ugly parentheses, which I asked you guys not to multiply out. Hey, I got something else out. I found my imposter. Equals to the limit h goes to 0 is negative 1 over x plus h plus 1 and a x plus 1. All right, now that we got rid of our 0 over 0, remember how this was 0 over 0 here? We got rid of it, bam, gone. We can now plug it in with no problem. Your parents have left the house. You can do whatever you want. Oops, sorry. I shouldn't have wrote that. When we plug it in, we don't write that anymore. We just write in negative 1 over x plus 0 plus 1, x plus 1. You can even skip this step, right? Because you guys all see that 0 is just going to go away, right? So we're left with negative 1 over x plus 1 squared. And this will be a rule that we're going to talk about later. But doing it by hand using limits, we got to be able to do this. Got one more. Last one is square roots. Okay, last one is square roots for today. Let me pause here. So our next example of a square root, we'll say square root of x plus 1. Just throwing that 1 in there. That makes it too simple. This is my f of x. So to find the slope, f of x plus h is square root of x plus h plus 1. See, the x just became x plus h. I didn't write the parentheses because plus 1 doesn't matter. It's not going to hurt it, okay? Save myself some time. I'm going to write our version. Limit h goes to 0 of our new version, x plus h plus 1, minus the old version, okay boomer version, and all divided by h. As you can see, it's our new versus the old. Okay, now the trick for this one, if you guys remember from pre-calculus and algebra 2, is to multiply by the conjugate. Just to verify, if I did plug in 0, if I plug in 0 there, aren't these exactly the same? This would have been 0 over 0 again. Okay, just to verify that. So try another method, and our method here is going to be multiply by the conjugate. Conjugate is square root plus square root. Take a look here, square root plus square root. And we're just going to copy the stuff inside x plus h plus 1, x plus 1, x plus h plus 1, x plus 1. How do I know that's a positive? If it's negative here, the middle changes for conjugates. That's why it's a positive there. Now, here is a reminder for you. If I write x plus 1 times x minus 1, this becomes x squared minus 1. There is no middle term. The reason why we multiply by a conjugate is because of square roots. What does a square do to a square root? Cancels it out, right? A square gets rid of a square root, cancels it out. So we don't have any more square roots on top. That's the main purpose of this. No more square roots on top. Yes, the bottom becomes trash, but that's okay. Limit as h goes to 0. We're going to jump to the square version of this. A square root times a square root cancels out to become just x plus h plus 1 minus square root and square root cancel out, becomes parentheses x plus 1 all over h, and just write the square root there. That's it. That square root is going to remain the same. That's the same square root. Same square root. So please don't freak out, and do not try multiplying it. Just leave it alone, because the top is going to clean up. He'll get all gussied up for his date tonight. And then he's going to get rejected. See? Rejected. See you later. So not only do we clean up the top, we reveal our imposter. Limit as h goes to 0. And we're left with just a positive h over h. You guys all see that imposter? Square root plus square root. We're just copying the denominator. And you can see that the h is now divided out. Rewriting this one more time, the limit, h goes to 0 of 1 over square root of x plus h plus 1 plus square root of x plus 1. Now, maybe I should write that a little nicer so you guys can see it. That's a little bigger. Square root of x plus h plus 1 plus square root of x plus 1. Okay, plug in the 0. Easy peasy, plug in 0 now. I plug in the 0. It turns out we end up with twins again. But be careful about these twins. They are not multiplying. They are adding each other. Oops, let's do that. Don't write limit anymore. If you write limit, gotta minus the point. Square root of x plus 1 plus square root of x plus 1. Since these are the same square roots, we have 1 over 2 square root of x plus 1. Now, I'm going to go ahead and draw this graph for you guys. F of x is square root of x plus 1, right? So the graph, make the square root go to 0. That's negative 1. And we're going this way. This is what the graph looks like. Looking at the slope is always positive, right? Always positive. Everyone agrees it's always positive. We're not dipping down. It's like a marriage. Super happy, then less happy, then kind of the same till you're dead. Okay? Super happy, and then I'm just kidding. Okay. So look at the square root. Now, if I plug in the number negative 1, if I plug in negative 1 here, see the negative 1? That becomes a 0. When, what is the f of negative 1? This is going to be 1 over 0. That's undefined. Because look, take a look here. The tangent line is perpendicular. That's going up and down. So it doesn't work, right? If you tip this over, this is actually a parabola, sideways parabola. Does this slope exist anywhere here? Look, is there any slope over here? The graph doesn't even exist. Guess what? If I plug in -2, f of -2, this would have been 2 square root of -1. Can we take square root of negatives? Nope. There are no derivatives here. And the derivatives don't work when the square root is negative. Totally read it. Totally predicted it. If I plug in 0, f prime at 0, that's 1 over 2. Hey, that slope here is not very strong. It's 1 over 2. As this problem gets a bigger, that makes the square root denominator become bigger, so the number flattens out to become 0. Okay? The denominator is bigger when a number fraction over a big number. Remember, that goes to 0. Okay, which is our slope. Our slope tapers out. Okay, that's it. That's what we're going to do to find instantaneous rate of change. We have our 3 different types: basic polynomials, fractions, and square roots.